breakdown method of measuring depreciation, part 2. Functional obsolescence. Functional obsolescence is loss in value due to inability of the improvement to perform adequately the function for which it is used. I need my other glasses. They're on my desk. They wouldn't be back by your coffee pot. Functional obsolescence is the loss in value due to inability of the improvement to perform adequately the function for which it is used as of the appraisal date. It includes physical or design features that are inadequate or undesirable by any current standards. An improvement that was functionally adequate when it was built can become inadequate or less appealing as design standards, mechanical systems, and construction materials change over time. Functional obsolescence is due to defects from within the materials, the improvement itself.
What? Start that sentence over.
Functional obsolescence is due to defects from within the improvement itself,
Oh.
while external obsolescence results from factors that affect the property, both land and improvements, outside of the property's boundaries. Functional obsolescence can be curable or incurable and can be caused by a deficiency or superadequacy, depending on whether the cost to cure is economically justified as of the appraisal date. Curable functional obsolescence exists if the current layout or design can be changed economically. For example, a bedroom next to the kitchen could be converted to a desired family room or den. Most often, however, functional obsolescence is incurable. A typical example is a room layout that could be changed only by cost-prohibitive remodeling, such as a bedroom that can be entered only through another bedroom.
Oh.
The types of curable functional obsolescence are as follows. Number 1, deficiency normal. Curable functional obsolescence caused by a deficiency requiring an addition, the absence of a component, or like, for example, no second bathroom when the market expects 2 bathrooms. Number 2, deficiency, modernization, substitution. Curable functional obsolescence requiring modernization or substitution is caused by something that is present in the subject property but is either substandard compared to other properties on the market or is defective and results in other components of the improvement not working properly, for example, an outdated kitchen. Superadequacy. Curable functional obsolescence due to a superadequacy typically results when an existing improvement component, which was included in the original construction of the improvement, exceeds the expectations of the market or provides little or no benefit to the owner, sometimes referred to as an over-improvement. The cost new of the superadequate item typically exceeds the item's component's contribution to value. The types of incurable functional obsolescence are as follows. Number 4, deficiency incurable. This is evident when the improvement is missing a building item component or design feature. For example, an improvement with exceptionally low ceilings, which is not economically feasible to correct on the date of appraisal. Number 5, superadequacy. Incurable functional obsolescence due to a superadequacy is when an item component of the improvement exceeds the market's requirements. This type of depreciation exists when there is cost without any corresponding increment in value or a cost that the increment in value does not meet. This type of depreciation exists when there is cost without any corresponding increment in value or a cost that the increment in value does not meet. Okay, that makes more sense. In most cost approach applications, the estimation of functional obsolescence attributable to incurable superadequacy is eliminated if the appraiser is using replacement cost. A simple example of the steps to use in measuring all forms of functional obsolescence, whether curable or incurable, follows. Utilizing the steps helps the appraiser to 1. Keep from making errors through the consistency of using the steps. 2. Ensure that no item is treated more than once. And 3. Eliminate the duplication of depreciation, especially in the measuring of superadequacy. Prior to beginning to measure functional obsolescence, the appraiser must investigate a cost to cure to determine whether the item of functional obsolescence belongs in curable or incurable category. 1. Cost of existing item less the depreciation which is already charged. Then step 1 less step 2 equals the depreciated value of the item, and that's added to 2, cost to cure, which is all cost, which includes cost of removal less salvage value plus installed new cost or value loss. 3, less cost if installed new. 4, functional obsolescence, curable or incurable. In the first step, the cost of the existing item is identified and listed. In measuring curable functional obsolescence requiring an addition, 0 is listed for the cost of the item since it was never part of the improvement in the first place. When the replacement cost, not reproduction cost, is used for the cost basis, typically 0 cost is listed for superadequate items. When reproduction cost is used, all forms of functional obsolescence present in the improvement are included in the reproduction cost of the new cost. All forms of functional obsolescence present in the improvement are included in the reproduction cost new of the improvement. I'm having a hard time, but I'll get there.
Are you reading too fast?
No.
Okay.
I can actually go faster.
No, don't. Because I can't. I'm having a hard time following.
Well, there's a lot of big, multi-syllable, syllabic words, and I'll get there.
We're from Texas.
You're from Oklahoma. The appraiser should identify and subtract any depreciation that has already been charged for the item in step 2. This depreciation typically is physical deterioration. If the item never existed in the improvement, as indicated in step 1, no depreciation would have been calculated and 0 is placed on this line. When curable functional obsolescence is being estimated, the third step is to sum all costs associated with curing the item. This includes the cost of purchasing and installing the new item, the cost of removing the old item, less any salvage value. When incurable functional obsolescence is being estimated, the third step is to add the value of the loss attributable to the obsolescence. This value can be obtained by the sales comparison, such as paired sales, or the capitalization of income method by using either a gross rent income multiplier or a capitalization rate. The fourth and last step is to enter the deduction for the cost of the item as though installed new on the date of appraisal. When curable functional obsolescence is being estimated, the combination of the third and fourth steps typically yields the excess cost to cure. Simply summing all the steps provides for the measure of curable or incurable functional obsolescence. These steps work for all types of functional obsolescence. Curable functional obsolescence. Curable functional obsolescence is measured by the cost to cure the condition. There are 3 types of curable functional obsolescence. 1, curable functional obsolescence caused by a deficiency normal requiring an addition. 2, curable functional obsolescence caused by a deficiency requiring substitution or modernization. And 3, curable functional obsolescence caused by a superadequacy. Normal deficiencies are not included in estimates of any form of cost new. A few items of curable functional obsolescence due to a superadequacy are not included when depreciation is estimated on a replacement cost basis. The following are examples of how to measure the three categories of curable functional obsolescence. Deficiency normal. A deficiency requiring addition is measured by how much the cost of the addition exceeds the cost of the item if it were installed new during construction of the improvement, the cost to cure.
Excess cost to cure.
Excess cost to cure. Something that does not exist in the structure being appraised cannot be depreciated. Therefore, a normal deficiency is measured by how much the cost of adding the item exceeds the cost incurred as part of the reproduction cost new. As an example, assume the current market expects residences of average quality. Yeah, that thing. Assume the current market expects residences of average quality to have central air conditioning, and the residence being appraised does not have central air conditioning as of the appraisal date. The current cost of adding the system is $9,800. If the work had been done as part of the new construction, the cost would have only been $5,600. Installing a typical air conditioning system would allow the property owner to charge a higher rent. Therefore, the gross rent would increase by an estimated $150 per month, or $1,800 annually. The current gross income multiplier, the GIM, is 7.0. The functional obsolescence is curable because of the value increase. 1,800 times 7.0 equals 12,600, and it is greater than the cost to cure, 9,800. The measurement of curable functional obsolescence normal deficiency is as follows. Number 1, cost of existing item, 0, less any depreciation already charged, minus 0, added to, number 3, the cost to cure, all costs, which is $9,800, or the value loss, which is 0, subtracting or less the cost if installed new, which is $5,600, gives number 5, the functional obsolescence curable at $4,200. In summary, when a component is added, the measure of curable functional obsolescence is simply the excess cost to cure. The measure is the same regardless of whether replacement or reproduction cost is used. Deficiency requiring modernization or substitution is measured as the cost of the existing items in the cost new estimate less the physical deterioration of the existing fixtures and salvage time, if any, plus the cost to remove the old fixtures and the cost to install the new fixtures. For example, a property requiring new lighting fixtures, that's the example, of property requiring new lighting fixtures. The cost new of existing lighting fixtures is $1,250, and the current fixtures are 68% physically deteriorated. The cost to remove the existing lighting fixtures is $600. The salvage value of the fixtures is $100, and the current cost of installing the new modern lighting fixtures is $1,875. The measurement of curable functional obsolescence, deficiency, modernization, or substitution is as follows. Number 1, cost of existing item, $1,250, less any depreciation already charged, minus $850. Then you add that amount to the cost to cure, all cost, which is $2,375, or the value loss, which is $0, and you subtract less cost if installed new, $1,875, giving a functional obsolescence curable of $900. In this example, the first two steps indicate the depreciated value of the existing item. $1,250 less the $850, and then it's bracketed calculated minus $1,250 times
No, it's
zero.
not minus.
It's not. It's a hyphen.
Yeah.
So it's calculated $1,250 times 0.68, which is equal to the $400.
68%.
In order to calculate all costs to cure in step 3, the appraiser must account for the cost of removing the outdated fixtures, $600, less the salvage value from the fixtures, $100, if any. This results in $500 and costs attributable to removal of the out-of-date fixtures. The cost to cure all costs is the sum of the $500 and the cost to install the modern fixtures of $1,875. The total cost to cure then is $2,375. Step 5 results in $900, the sum of the $400 from steps 1 and 2 and $500 from the difference in steps 3 and 4. For functional obsolescence to be curable, the increased market value of the property after obsolescence has been cured must be at least equal to the cost of the item if originally installed during construction. Superadequacy is a condition in which the component is more than adequate for its intended function. It can be measured by using the functional obsolescence steps shown above. Superadequacies are structural components of higher quality and cost than are required under current market standards. A superadequacy is a form of functional obsolescence that is rarely curable in some improvements, such as single-family residences, when there is nothing to be gained by removing the superadequate item. In a replacement cost new estimate, theoretically the cost to replicate the superadequate item is not included in the cost new estimate. However, the cost to cure the superadequate item is still valid. Superadequacy can be illustrated in the following example of an industrial warehouse built for a vegetable wholesaler who included excess cooling capacity to prevent the loss of many perishable vegetables sold to local restaurants and fast food establishments. The property is no longer being utilized for storage, and sale of perishable vegetables is available for rent. Currently, the industrial warehouse market does not require the excess cooling capacity that is inherent in the subject property. The current reproduction cost of the existing heating and air conditioning system is $30,000, and the component is 30% depreciated. $30,000 per acre times 0.30 depreciation, which is equal to $9,000. Removal of the superadequate item costs $3,750. The salvage value is $6,000, and installation of a heating and air conditioning system with typical capacity for the market costs $16,500. The total cost to cure is then $14,250 in step 3, which looks like $3,750 minus $6,000 plus $16,500. If a normal capacity heating and air conditioning system had been installed as part of the new construction, the item would have cost $12,000 and saved the property owner $150 per month in excess electricity costs and maintenance expenses. By using a building capitalization rate of 9%, developed from an analysis of comparable sales, the value cost savings is $20,000. $150 per month times 12 months divided by 0.09, which exceeds the cost to cure. Therefore, the item is curable. Curable functional obsolescence due to superadequacy is 30,000 minus 9,000 equals 21,000 plus 14,250 minus 12,000 equals 2,250 equals 23,250.
So the reproduction cost of the existing heating and air conditioning, 30,000 minus 9,000 in depreciation is 21,000. Added to the total cost to cure of $14,250 minus 12,000 in the original cost if they would have installed it brand new.
A normal capacity.
A normal capacity equals $2,250.
So then the 21,000 plus the $2,250 is $23,250.
Boy, you really gonna study that? Okay. It's hard to follow. Oh, here's a chart.
It's on this. It's a chart on the next page. Yeah.
Okay.
The following shows the step-by-step calculation for curable functional obsolescence super adequacy. Cost of existing item 30,000 less any depreciation already charged $9,000. You're going to add that to cost to cure all costs, which is $14,250. There is no value loss, so that's zero. Less the cost new if installed new, which is $12,000, which the functional obsolescence curable is the $23,250. Incurable functional obsolescence. Incurable functional obsolescence is a condition that decreases the utility of the property and is not economically feasible to cure as of the date of appraisal. It may be caused by deficiency or a superadequacy. There are two tests of curability for functional obsolescence caused by a deficiency or superadequacy. First, if spending the money to cure the item results in a value increment equal to or greater than the expenditure, the item is normally considered to be curable. Second, if spending the money to cure the item does not result in a value increment equal or greater than the expenditure, but allows existing items to maintain their value, the item is considered curable.
What's the matter?
I just didn't think we needed the air on. It's not that hot.
Well, you were complaining about it being hot
Earlier.
Oh.
Incurable functional obsolescence due to a deficiency, an item that is not included in the cost estimate but should have been, is measured as the net income loss attributable to the deficiency in comparison with otherwise competitive properties. The net income loss attributable to the deficiency is divided by the improvement's capitalization rate, which is developed in the income capitalization approach. For income-producing properties, capitalizing the net income loss is a standard procedure. An alternative method is to multiply the net income rent loss due to the deficiency by the GIM or GRM. Using the steps listed below to measure the incurable functional obsolescence helps eliminate mistakes. First, identify the cost of the existing item. If the existing item is a form of functional obsolescence that was never part of the structure in the first place, there is no cost for the item and a zero is entered in step 1. If replacement cost rather than reproduction cost is used for the cost basis, typically there is no cost allotted for any super adequate items. In step 2, any depreciation that has already been charged for the item is deducted. As in the first step, if the item does not already exist in the structure, no depreciation is charged and zero is entered. In step 3, the value of the loss attributable to the obsolescence is added by either A, capitalizing the net income loss using an income multiplier or a capitalization rate, or B, through analysis of comparable market data such as paired sales. In step 4, a deduction for the cost of this item as though installed new on the date of the appraisal, if appropriate, is entered. The measurement of incurable functional obsolescence is simply Summing of all the steps. Solving for incurable functional obsolescence, normal deficiency can be illustrated in the following example. A 4-story office building was built when elevators were not required for commercial properties. However, current requirements call for elevators. If an elevator could be installed, the rents on the top 3 floors would increase and $15,000 in gross income could be gained. The office building requirements when the improvement was constructed are different than the current construction requirements of office buildings with elevators. The historical construction of the improvement is not structurally designed for the current installation of an elevator system. As a result, the income loss due to the lack of an elevator system continues into the future. Market analysis indicates GIM of 6.0. Since no elevator can be installed, the lack of an elevator is incurable functional obsolescence, normal deficiency, and is estimated by multiplying the GIM of 6.0 by the income loss of $15,000, resulting in an estimate of $90,000. The following shows a step-by-step calculation for incurable functional obsolescence, normal deficiency. Cost of existing item, 0, less any depreciation already charged, 0, added to the cost to cure, all costs, 0, or value loss, $90,000, less the cost of installed new, 0, functional obsolescence curable, $90,000.
Okay, I kind of get that. Because it wasn't there in the first place. You're not replacing something. You're thinking about how much value is lost on this property because it doesn't have an elevator like other properties of similar utility or use. So you're not adding in any costs or anything. Okay. Continue on.
Incurable functional obsolescence. Superadequacy occurs when a property component exceeds what the market requires. It represents a cost without any corresponding increment in value. Typically, in the cost approach, if the appraiser is using replacement cost, the need to estimate incurable functional obsolescence superadequacy is eliminated because superadequacies are not replicated in the replacement cost estimate. Regardless of which cost estimation method is used, and any extraordinary expense of ownership attributed to the superadequacy must be quantified and deducted as value loss to the improvement. Superadequacies often are difficult or impossible to cure, hence the category incurable functional obsolescence superadequacy. For example, the subject is a historical 3-story residence and has ceiling heights of 12 feet on the first floor and 10 feet on the upper 2 floors. The cost of a historical residence worth of varying heights is $600,000, whereas the cost of a typical 3-story residence is $500,000. The subject residence costs $2,500 more per year to heat and cool than comparable properties in the subject's improvement market area. The extra $100,000 spent in the original construction on the extra ceiling heights add to no value to the property, and there is no reasonable cost to cure. In the current market, the excess ceiling heights would not be constructed in a substitute property. As a result, the amount entered on the functional obsolescence table as cost if installed new is 0. The excessive floor ceiling heights cost to the subject improvement an additional $100,000 annually over comparable improvements. In the income approach, the building capitalization rate in the subject improvement market of 10% has been derived. Incurable functional obsolescence superadequacy is estimated to be $25,000, $2,500 divided by 0.10. Because the item is superadequate, it does not belong in the structure and there is no correct replacement component. Thus, in the functional obsolescence table under Step 4, there is no entry. The following is the step-by-step calculation necessary for incurable functional obsolescence replacement cost. Cost of existing item, 0. less any depreciation already charged, 0. Cost to cure, all costs, 0. Value loss, $25,000. Less cost if installed new, 0. Functional obsolescence, curable, $25,000. With these data, but now using reproduction costs instead of replacement costs, the additional $100,000 of the superadequacy is not eliminated. The incurable functional obsolescence superadequacy is measured as the cost of the superadequacy less the physical deterioration already charged, plus the capitalization additional cost of ownership. Assume that a 10% charge has already been applied in the measurement of incurable physical deterioration due to the excess ceiling heights. The incurable functional obsolescence superadequacy is the cost of the superadequate item, $100,000 for the extra ceiling heights, less the physical deterioration already charged, 100,000 times 0.10 equals $10,000, plus the added cost of ownership, $25,000, which equals $115,000. I can't think. The following is a step-by-step calculation for incurable functional obsolescence superadequacy, reproduction cost. Cost of existing item, $100,000. Less any depreciation already charged, minus $10,000. Added to cost to cure, all costs, 0, or value loss, $25,000. Less cost if installed new, 0. Functional obsolescence curable is $115,000.
And I might read that a little different next time. 100,000 minus 10,000 plus 0 for the cost to cure. Value loss is plus 25,000.
You're adding it.
You're adding it in. So I would, if you're adding it in, I would say plus. Plus it. Plus. I mean, just let me know later when I'm listening that it's I'm adding it in, not subtracting it out.
Well, that's
because it says value loss, which until I get that straight in my head.
Oh, I see what you're saying.
I'm going to think of subtraction
because of loss for value loss.
Adding that.
Okay.
So how about we reread that little section?
Cost of existing item, $100,000, less any depreciation already charged, minus $10,000, added to cost to cure, all costs, 0, or value loss, add $25,000. Add $25,000.
25 to 25.
To 25. Less cost of it if installed new, $0. Functional obsolescence curable is $115,000. End of section.